Welcome to another linear shorts video. I haven't done these in a while and I'm gonna try to make the promise to keep it short. So in this video we are going to discuss about the dot product. How does it show up? Why does it show up? What is this? What is a dot product? Okay, so I don't want to waste enough time, so let's get into it. So let's say we got two vectors and I did not name them. So let's say we got two vectors. This vector has a magnitude of v, and then this other vector has a magnitude of w, so we won't get confused with the u. Cool. And they're separated by some angle phi, and we know that is also separated by some distance, that is w minus v. And so, yo, what do we got here? We got a triangle, back in geometry, we talked about triangles and stuff, circles. Okay. So what else did we discuss about in geometry other than triangles? Well, we discussed about the law of cosine. And if you remember this beautiful equation, the law of cosine tells us that c squared is equal to a squared plus b squared, whoa, Pythagorean theorem, minus 2ab, yeah, b times cosine of theta. So now we can just plug and chug, and so we'll get that this is our c, this is our c, this is our a, b, and this is our theta. So we'll have the magnitude of w minus v, quantity squared, is equal to v squared plus w squared. I mixed those two. That's commutative. W squared minus 2v w cosine of phi. Well, before I move any further, we are going to work in a plane. So r is 2, so that means v consists of xy, and then w consists of xy as well. xy. But we are going to continue with the algebra. This portion here, we are going to separate it into components. So what we'll have here will be w1 minus v1 quantity squared, plus w2 minus v2 squared, and then this is equal to if you remember what the magnitude is, it is the square root of something. So when you take the square, that square root is gone, so you're just left with the components quantity squared. So for v squared, it will be v1 squared plus v2 squared, and then w will be w1 squared plus w2 squared, and then we are gonna keep the 2 minus that thingy alive. It's minus 2 v w, because there's nothing much we can really do, cosine of phi. And then we are going to expand this part, so I'm going to go ahead and move here. So this would be w squared plus w1 squared, Jesus, w1 squared plus v1 squared minus 2w1 v1, and then plus w2 squared plus v2 squared minus 2w1 v1. No, 2 w2 v2 is equal to v1 squared plus v2 squared plus w1 squared plus w2 squared minus 2 magnitude of v magnitude of w cosine phi. And what do we have here? Hello. We have w1 squared, v1 squared, w2 squared, v2 squared, v1 squared, v2 squared, w1, w2. We can cancel these out, and we are left with -2, and factor out the -2, -2 w1 v1 minus w2 v2, not minus, it's supposed to be a plus. No, yeah, plus, plus, because I factor out the negative, is equal to -2 magnitude of v magnitude of w cosine phi. You can take out that -2, divide both sides by -2, and then we're going to move the magnitudes on the other side. And so what we get is cosine, or I guess w1 v1 plus w2 v2 over the magnitude of w and v, or the product of the magnitude of w and v, is equal to cosine phi. And so this part right here, all this, the numerator, that is our dot product. So we can simplify that to w1 v1 plus w2 v2 to v, or I guess w dot v. And this will hold true in every dimension. The only reason why we did r is equal to 2 because when you expand it, it becomes much more simpler. You go in a higher dimension, you kind of have to use like the whole binomial theorem and whatnot, but eventually things will start to cancel out and you'll be left with this same equation. So in general, it will just be w1 v1 plus w2 v2 plus w, or plus all the way to wn vn. And that is the, I guess, proof. Not much, I guess you could say it's proof, but that is where the dot product comes from. It's just a way of saying, oh, we're just gonna shorten this part out by just saying w dot v. So that is pretty much the proof for this dot product, and we are under 10 minutes, so I consider that as a success for a linear short. So hopefully you find this useful, helpful, a little aha moment of why this showed up, and I will see you guys in the next video.